Dear student, welcome. Today we are going to start a fresh new extremely important topic, that is Bohr atomic model and hydrogen spectra. Previous class we have discussed about the failure and reason of failure of Rutherford's atomic model. According to Rutherford's atomic model, electron revolves in circular path, and as we know, each and every circular motion is accelerated motion. So when electron revolves around a nucleus in circular motion, according to Maxwell's electromagnetic theory, if any charged particle possesses accelerated motion, they must radiate energy, and that's why electron revolving around nucleus in circular path release energy continuously, and subsequently path decreases and finally trapped in nucleus by following a spiral path, and it will happen only in 10 to the power minus 8 second. And when electron trapped in nucleus, atom will collapse, because this goes against the experimental observation of alpha scattering. After failure of Rutherford's atomic model, a large gap is in between proposal of new atomic model and the new atomic model given by Bohr on the basis of his assumptions. His assumptions was, of course, at that time not explained theoretically, not explained well by Bohr itself, but after discovery of wave mechanical mode of electron particle wave particle duality, it becomes that his assumptions was correct. Now we are going to start Bohr's atomic model and hydrogen spectra. तो बोर्स एटॉमिक मॉडल में सबसे पहले बोर ने कुछ एजम्पशंस किया, और उसमें से पहला एजम्पशन था he assumed that electron of course will revolve in circular path but not in any arbitrary circular path, rather only certain discrete value of angular momentum of electron is permissible. That is, electron can revolve only in those orbits in which angular momentum of electron is integral multiple of h by 2 pi. That is, angular momentum of electron is quantized. Electron can revolve in those orbits in which angular momentum is integral multiple of h by 2 pi. If n is equal to 1, then in first orbit, angular momentum of electron will be h by 2 pi. If electron revolves in second orbit, then its angular momentum will be, if n is equal to 2, angular momentum is equal to h by 2 pi, and so on. Later on, this n is specified as number of orbit and principal quantum number. So, first assumptions of Bohr's atomic model was electron revolves only in those circular path. Electron revolves only those circular path in which angular momentum of electron is integral multiple of h by 2. That is, mvr is equal to nh by pi. And the second assumption of Bohr was, if electron revolves in such an orbit in which angular momentum is integral multiple of h by 2 pi, they will not radiate energy even if their motion is accelerated, and hence these orbits are termed as Bohr's stationary orbit. If electron revolves such an orbit where angular momentum is integral multiple of h by 2 pi, they will not radiate energy. They will not radiate energy, and if they will not radiate energy, and if sun is accelerated, and hence these orbits are termed as Bohr's stationary orbit, and hence These orbits are termed as orbit. Means Bohr's stationary orbit are those orbits in which angular momentum of electron is quantized and the quanta is h by 2 pi. And angular momentum can vary through h by 2 pi. If it is first orbit, angular momentum is h by 2 pi. If it is second orbit, 2h by 2 pi. Third orbit, 3h by 2 pi, and so on. Third assumptions of Bohr's atomic model was stated that if electron is present in any initial Bohr's stationary orbit, and if we want to jump in another orbit n final, they can do so by absorbing or emitting appropriate amount of energy. Of course, absorption or emission of energy will be exactly equal to difference in energy level of this orbit. Means electron can jumps from one Bohr's stationary orbit, one Bohr's stationary orbit, other by absorbing or appropriate amount, and this appropriate amount of energy is nothing exactly energy difference stationary orbit. Appropriate absorbing or emitting appropriate amount of energy, and of course, as we know, energy absorbed or emitted in form of electromagnetic radiation, so this energy will be absorbed in form of hc by lambda, that is a specific electromagnetic radiation having certain wavelength, either absorbed or emitted depending on value of n initial and n final. If n initial is lower, n final is higher, electromagnetic radiation is absorbed. If n initial is final, n initial is lower, then electromagnetic radiation of this much wavelength will be. These are three assumptions of Bohr. The most important thing now, what is the distance of first Bohr orbit from nucleus? If electron can revolve in different orbit, in which angular momentum electron integral multiple of h by 2 pi, then what is the distance of first Bohr's orbit, second Bohr's orbit, and so on, nth Bohr? If distance of electron from nucleus is different, then of course their speed, tangential speed will be different. What is the velocity of first orbit and in second orbit, and so on orbit? And if distance of charge from one particle to the differs, if velocity differs, then kinetic energy and electrostatic potential energy will be different. So different orbit having different energy, E1, E2, and En. So now the most important task is, what is the radius? What is the radius of nth orbit? If orbit is nth orbit, then what is its radius? What is velocity of electron? And what is the energy of electron? And this calculation has extreme importance because most of the numerical of hydrogen spectra and atomic structure started from this topic. So first of all, first assumptions of Bohr, from assumption of Bohr, we know angular momentum of electron multiple of h by 2. And secondarily, Bohr assume the kinematics of electron according to mechanics. And if electron revolving around nucleus having negative charge, nucleus has positive charge, and which is equal to Ze plus. Z is the number of proton in nucleus, that is atomic number, and E plus is charge of electron. You can say Ze plus is 1 and minus electronic charge. And if two charges separated with a distance r, then force of attraction according to Coulomb's law will be Q1 Q2 by R square constant, and this K is 1 by 4 pi epsilon is the medium between, if the medium between charge is free space. So there is electrostatic force of attraction operated between electron and nuclei, and its value and its value is Q1 Q2 by 4 pi epsilon, and of course Q1 is ZE plus, Q2 is E minus by 4 pi epsilon RS. And this is the electrostatic force of attraction operated between electron and nuclei. This electrostatic force of attraction provide necessary centrifugal force for electron to revolve around nucleus. As we know, for each and every centripetal circular motion, a force towards the center is necessary, and the force is named as centripetal force, and the value of centrifugal mv square by r. If electron has no motion along the electron and nucleus axis, they have to revolve for infinite time in their circular orbit. Then along this axis, net force, neither electron drifted towards nucleus, not away from nucleus. The stationary orbit. Electron will revolve for infinite time in the, means this axis no net force should be operated on electron. And according to Newtonian mechanics, a pseudo force was imagined, that is centrifugal force, which balances centripetal force, and the value of centrifugal force equal to just opposite and equal to centripetal force, that is minus mv. So now from the kinematics of electron, we get one most important equation which will help in deriving the energy of nth orbit, velocity of nth orbit, and radius of nth orbit, and that is centrifugal force of electron. Centrifugal force of electron minus mv square by r, balanced by electrostatic force of attraction, which will be equal to centrifugal force, and this is minus ZE square by 4 pi epsilon r square. Means from kinematics of electron, we can write mv square by r equal to ZE square by 4 pi epsilon. And from equation 1 and 2, we can calculate the value of r. From equation 1, r is equal to nh by 2 pi, our equation. And from equation 2, get r is equal to ZE square by 4 pi epsilon mv. And if LHS of two equation is equal, then RHS must be same. So we can say NH by 2 pi mv will be equal to ZE square by 4 pi epsilon mv. Clear? So from equation 3 and 4, from equation 3 and 4, get ZE square by 4 pi epsilon square will be equal to NH by pi m in. From m to m, is cancel out, s square 4 left by 2 pi, we can say equal to ZE square by 2 epsilon. One of the most important and desired equation we get is velocity of electron in nth orbit. If electron is revolved in nth orbit, we have to give the value of n, and we can say sum of value which is constant is independent of nature of atom, that is electronic charge independent of orbit of electron, and in which atom there is electron revolving has nothing to do with them. H Planck's constant, epsilon constant, two constant. Only Z and N is variable, which depending on the number of atom and the number of orbit in electron was revolving. So reduced formula I get velocity of nth orbit is equal to Z by N 0.18 10 to the power 6 meter per second. Remember, constant by constant into the constant, and Z and N has number. This constant has the unit of velocity. हमने कुछ नहीं किया, ये स्क्वायर h साइलोन 2 के वैल्यू को रखा और ये वैल्यू हमारा कैलकुलेट हुआ. आप कैलकुलेट करके velocity of nth orbit के बाद now we can get the value of r either by putting the value of v in equation 2 or by putting the value of v equation 3. Okay, so we can get the value of r by putting value of v in equation 3 or 4. In 4 there is more number of quantity than third, so it is easy to calculate the radius of nth orbit by putting this value v in equation third, that is r is equal to nh by 2 pi mv. So now we have to put the value on the same page. Radius of nth orbit is equal to nh by 2 pi m, and instead of v we will put this ZE square by 2 epsilon n, ZE square by 2 epsilon nh cancel out, and we get r is equal to epsilon n square h square pi m ZE. Radius of nth orbit is equal to epsilon n square h square pi m ZE. So if radius of nth orbit is epsilon n square h square pi m ZE square, so if constant reduced, radius of nth orbit is equal to n square, so 0.529 angstrom, and the value of Z will be intact. Epsilon is constant, again h is constant, pi constant, a mass of electron constant, electronic charge constant. Each all constant value put and calculated, they will get converted into 0.529 angstrom, because n and Z has no unit, and LHS is radius, which distance is length of length, and so on. And as we know, 1 angstrom is equal to 10 to the power minus. So now we have two equations, radius of nth orbit and velocity of nth orbit. Remember, velocity of nth orbit was ZE square by 2 epsilon n. Velocity of nth orbit is ZE square epsilon ZE square epsilon nh, the velocity of nth orbit, and radius of nth orbit is equal to epsilon n square h square pi m ZE. For convenience, for numerical calculation, we can use reduced formula. N is equal to Zn 0.18 10 to the power 6 meter per second, and radius of nth orbit is n square by Z 0.529 angstrom. The main equation is this, the reduced formula. You have to remember only the constant value, and Z by N already constituted in main equation, N square by Z already contained in main derivation. So now it is quite easy to calculate the total mechanical energy of electron in it. Now energy of electron in nth orbit. total mechanical energy of electron A will be equal to kinetic energy plus electrostatic potential. As we know, kinetic energy is half mv square and electrostatic potential energy q1 q2 by 4 pi epsilon r. Remember, electrostatic force of attraction is 4 pi epsilon q by r square, whereas electrostatic potential energy q1 q2 by 4 pi epsilon r. 4 pi epsilon r. Electrostatic potential energy suppose as work done required bringing unit positive charge from the point, that is equal to work done, that is F dot R, and electrostatic force of attraction as we know 1 q by 4 pi epsilon r square into R. So electrostatic potential energy will be q1 q2 by 4 pi epsilon r. Now we have to put the value of R and V and we will get total energy of electron in orbit. Let us see. Kinetic energy is equal to half m, and abhi we can put the value ZE square by 2 epsilon NH square plus Q1 is electronic charge and Q2 is ZE plus. One charge particle is nucleus and other charge particle is electron which is revolving around it. So ZE square plus ZE minus and E plus will be equal to negative minus ZE square by 4 pi epsilon. Instead of R, can put the value of epsilon n square h square. Epsilon 4 pi ZE square by 4 pi epsilon n square h square pi m ZE. Pi to pi cancel out. Now the overall kinetic energy is equal to m z square e power 4 square 4 and 4 into 2 8 epsilon square n square h square plus minus minus m z into z square into e square e power 4 by 4 epsilon into epsilon square n square. The total kinetic energy will be equal to common m z square e power 4 epsilon square n square h square is common 1 minus 8 1 by 8 minus by 4, and so total energy, this value is equal to minus 1 by 8. Total energy will be minus mz square e power 4 8 epsilon square n h square. The most important derivation, that is energy of nth orbit of electron, and the negative sign before total energy indicates that electron and nucleus is bounded system, and if we have to remove electron from atom completely, we have to supply. And in entire electromagnetic spectrum, hydrogen spectrum, we have the most important orbit. So let us consider again another expansion. If energy of nth orbit is equal to, if energy of electron in orbit is minus m z square power 4 8 epsilon square n square h square. Again we know m mass of electron is constant, electronic charge 1.10 to the power minus is constant, epsilon permittivity of free space h tanks constant, and it is also shallow. So constant into constant by constant are constant, and energy of nth orbit becomes minus z square by n square minus 18 10 to the power minus And another popular unit of energy is electron volt, and 1 electron volt is equal to 1.10 to the power minus some, right, as z square by n square minus 13 point. And now if we have to discuss hydrogen spectra, we have to apply the equation of nth orbit of energy in hydrogen. For hydrogen atom, if it is applied, then Z will be equal to, and the formula now reduces to energy of nth orbit minus 13 by ns. Quite simple. If electron is present in n is equal to 1, that is first orbit, it has energy equal to minus 13. And if the electron revolving in equal to 2, energy will be electron. If electron is revolving n is equal to 3, its energy will be minus 5 electrons. And if electron revolving in 4, it will be 0.. And at if it is energy electron, whenever energy of electron becomes non-negative, that is 0, electrons supposed to move from atom, because if electron is at nth equal to infinite value, then electron has no influence. And we have definition of removal electron. When electron is far away from its nucleus, that is at infinite distance, it is termed as removed completely from it. So whenever electron lie within an energy is negative, as it becomes free from it, 0 or positive. This minus 13.6 electron volt energy level is the lowest energy level, and hence n is equal to 1 is termed as ground state. In ground state, energy is lowest, is highest. Onward 1 from 2 to 1, all energy state is known as excited state. N is equal to is first excited state, n is equal to second excited state, and n is equal to 4 is third excited state. One the most important thing, energy difference between first and second orbit is round about of 10 point electron, whereas energy difference between second and third orbit is only 1.5 electron volt, and as we go up, energy difference only 0.7 electron volt. So as number of n value increases, energy difference decreases, and at subsequently high n value, all Bohr's stationary orbit energy level appears as coinciding with each other, having very fine gap. So these are the most important facts of the Bohr's atomic model. Now, hydrogen spectra, how to calculate the electromagnetic radiation absorbed or emitted during any jumping. So if electron is present in an initial and jumped in final orbit, the energy orbit is delta E, and this energy either absorbed or emitted of electromagnetic radiation has certain wave. And as we know, delta E equal to hc by lambda. So this delta E will be equal to energy of n final orbit minus energy of initial orbit, and energy of final orbit will be equal to minus mz square e per power 4 8 epsilon square n final square, and energy of n initial orbit is minus mz square e per power 4 8 epsilon square n initial square. Value of energy only differs by number of orbit from where they was present initially. So initial orbit having energy is equal to only Ni, and final orbit having n final, rest quantities are constant. And this is the value of delta E, that is, this is the value of hc by lambda. So we can rewrite these equations from minus to minus left side. we can rewrite 1 hc by lambda equal to hc by lambda is equal to m z square per power 4 epsilon square n initial square h square minus mz square per power 4 8 epsilon square n final square and h square, and so hc by lambda is equal to m per power 4 epsilon square h square constant and 1 by l square minus by n final square, and the 1 by lambda is equal to hc from this side will be equal to m per power 4, and remember z separately placed, m e per power 4 by 8 epsilon square h square and h cube c z into 1 by n initial का square minus 1 by, these all quantities are constant, and a constant into constant by constant a constant. So 1 by lambda is equal to r, termed as Rydberg constant in honor of the scientist, r z and z square 1 by n initial का square by n final. Remember, if it is applied for hydrogen spectra, for the case of hydrogen, then z square becomes 1, and we may nullify this. If it has to apply for hydrogen like atom, that is like helium plus, lithium plus plus, then z value will be intact. So overall equation for calculating the wavelength of electron jumping from n initial to n 1 by lambda is equal to r z square 1 by n initial square minus 1 by n final. Remember, depending on the value of n initial and n final, lambda may be positive or lambda may be negative. Lambda positive only when n initial is smaller and n final is higher. If this is smaller, larger, and if it is large, value will be small and lambda will be positive. And if n initial is higher, n final is lower, then it will be negative. So lambda positive negative has only the sense of whether energy absorbed or emitted during lambda. Remember, lambda is the distance point to distant or to curve, so it never be negative. Point never be negative. So negative lambda nothing. Wavelength of this much electromagnetic radiation is emitted, and if lambda is positive, then electromagnetic radiation of much wavelength is absorbed. So now we can calculate easily the value of lambda when electron jumps from one orbit to other orbit. That is for hydrogen spectra like Lyman series, Balmer series, Paschen series. When electron jumps from one orbit to other, energy absorbed or emitted, and in large number of electromagnetic spectra emitted, this spectra was classified on the basis of final destination electron, and if electron finally jumps to first orbit, whether it will be from second, third, fourth, and so on, for emission spectra, the line was termed as Lyman series. The line was, all electromagnetic radiation was termed as Lyman series. If electron finally jumps to second orbit, whether from 2 or 3 or 4 or so on, termed as Balmer series, and likewise Paschen bracket Fund and Humphreys. Now all lines of Lyman series lies in ultraviolet region. All lines of Balmer series region, and Paschen bracket Fund and Humphreys are in infrared and far. So this is the calculation of radius of nth orbit, velocity of nth orbit, And in energy of nth orbit of electron, radius of nth orbit is equal to n square 0.529 angstrom. For hydrogen spectra, radius of velocity of nth orbit is equal to energy of nth orbit is equal to minus 13 by n square electron volt, expressed as joule also, and velocity of nth orbit is equal to z by n, that is plus 1/8 into 10 to the power 6 meter per second by. So these are the three most important formulae, and the fourth one is 1 by lambda is equal to rz square 1 by n initial square minus 1 by n final square, where r is Rydberg constant having value 1.10 to the power minus 7 per meter inverse of lambda. So after knowing this value, we can calculate the numerical. And in next class, we will discuss the numerical value. Thank you very much. Try the topics, try the derivation of equation, and then we will solve the question. Okay, thank you very much.